welcome. Today, we are going to explore the next evolution of AMI, and I'm very excited to dig in. So I'm not going to spend too much time, but before I do, I kind of want to set the table before we introduce our first guest. We are going to talk about a smart meter that has acoustic leak detection embedded inside of the meter. Leak detection, especially in service connections, is usually time-consuming, inefficient, and can be expensive. Kamstrup is truly committed to fighting water loss, and they have developed the industry's first smart meter with acoustic leak detection embedded inside of the meter. The technology gives utilities full transparency of their distribution network and gives them an efficient leak detection tool. After all, if you don't know where your distribution network is leaking, how can you offer the best service to your customers? And that's what's most important, and that's what we're going to talk about today. So I'm going to go ahead and introduce our guest, and I'm very happy that he's on board here, and I appreciate him giving us some time. So please let me introduce to you Joe Ball, the Vice President of Product Management and Business Development here at Kamstrup. Joe, welcome to the show.
Thanks, Travis. Really excited to be here. Excited to be here to talk to you about the technology that Kamstrup's developed that's really helping our customers address not only the standard use cases we see with AMI, but also going further and helping them address any of their non-revenue water problems with our embedded acoustic leak detection in our meters. So really look forward to chatting with you today. So let's kick it off then.
Let's dive into it. And where I typically like to start, especially when we're talking about innovative technologies, is the why behind it. So if you wouldn't mind sort of setting the table here and explaining to the Water Online audience why this technology came into development in the first place.
Yeah, so Kamstrup has got a long history of working with ultrasonic meters. We've been doing ultrasonic meters for 30 plus years. And when we look at our metering technology, especially as we bring it into the North American market, we're looking at a lot of the strengths we get from ultrasonic metering, which is the accuracy that we can measure water over the 20-year life of that meter, and also the ability to pick up that low flow at those particular residents. And then when we really push the boundaries and see what else can we do with this technology, the team a few years ago started to look into it and understand that they could use that ultrasonic technology to also be able to listen to acoustics and detect leaks that were out in the distribution system. So they just kind of went, did more and more testing, worked with some customers to develop and really refine that technology that we brought to market a few years ago.
So it's already been finally tested and ready to rock and roll here. So we're excited about that. So to get into a little bit more detail about the specifics of the technology, I'm curious, what does embedded inside the meter mean exactly? And how does it differ from anything related to adding the acoustic outside the meter? So what's the difference there?
The embedded inside for Kamstrup means we use those same transducers that we use to measure flow within the meter to also be able to listen to the acoustics. So that gives us a bit of a benefit than the external acoustic leak sensors that are out there in the market, because we can not only listen and hear the acoustics, but we also are measuring flow. So we can specifically determine whether that is a utility side leak, so in the distribution system, or it's a customer side leak. And we can do that because we could hear the noise that's being generated in the distribution system, as well as knowing the flow that's going through that meter at that time. So really interesting technology, gives us the ability to make that distinct confirmation between utility side and customer side.
So I don't want to understate the importance of that. Having the utility actually having the ability to say, all right, is the leak with us, or is the leak all the way over when the customer side of the distribution network? That's an important thing to know, and an advancement that the market and the industry really needed. So I applaud you for that. I want to go even deeper though. If I'm speaking on behalf of a utility, so if I'm working for a utility, and obviously the need is probably there because all utilities want to know where their leaks are coming from, but why should we consider acoustic leak detection as it relates to having the detection and the technology inside the meter versus the traditional outside?
Yeah. For us, I'm a bit biased, right? Kamstrup, really involved with the product side of it here. The reason that I think they should look at it in an embedded solution in the meter is because it's a very clean solution. You don't have additional equipment that's being installed in the distribution system. You don't have additional communications that you're worrying about. In our meter, it's a very clean integrated unit, meaning that the acoustics are embedded in there. The communications are also embedded in there, so you don't have a lot of wires that are in there. So it gives them the ability to invest in an AMI solution and they get the acoustic leak detection as a bonus with it, with really no additional capital cost.
As utilities go through what I like to call digital transformation, as they're becoming more reliant on data collection and online and being able to digitize their systems, you're only as good as what the data shows you are. So I want to speak for a minute, or if you could speak for a minute about the accuracy of ALD. So when it comes to accuracy and the accuracy of the data, could you talk a little bit more about that?
Absolutely. So, from an accuracy perspective, there's a few different points there that I'll talk about. So, with the ALD solution or the acoustic leak detection solution that we have, every residential meter, at least from 5/8 to 1 inch, has that technology in it. So, you have in your distribution system could be thousands, tens of thousands of acoustic leak sensors. So we'll grab all that data from each one of those meters and bring that back into our software to go ahead and analyze that data. And effectively, the software uses machine learning to be able to take a look at the historic noise and to be able to identify where there's potential leaks, and then where there's warnings, meaning that there's noise out there that's increasing, but it's not necessarily at the higher level of the meters that you want to go out there and address straight away. So there's the accuracy there of a lot of different data points, machine learning, and the history of the noise that's out there that's giving us the ability to point them in the direction. So once we point them in that direction,
no, go ahead.
Once we point them in the direction, then we have the ability with all those different metering points to kind of narrow down where the utility has to go and use some correlation or listening devices to be able to actually find where they're going to dig. We don't pinpoint the leak. No acoustic leak sensor really pinpoints the leak, but we get them pretty darn close based upon the number of meters that are out there and the way our software works.
Did you say thousands of data points?
Yes, I did.
When we're talking in the thousands, that's something. I don't want to blow past that. I mean, you're only as good as what your data shows you are. And when you have that many data points, man, that certainly helps you be accurate.
That's true. Can I give you one other point there too, John?
Yeah, absolutely.
Because the thousands is the number of meters that are out there. And then maybe if we talk about how we sample that data or the sampling that goes on there. So we actually listen 26 times during the day. We do that on 55-minute increments. And we go ahead, and that way it gives us the ability to listen for noise that's out there throughout the day. And when we report that data back through our system, we actually are reporting back at the most quiet time. So some systems will take a look at, a certain like 2 a.m. every day, but there could be noise at that 2 a.m. every day, or on some days there could be noise. So by going and taking those 26 different samples, we're actually taking a look at that data throughout the day, bringing the quietest information back to get the best result.
So with all of those meters that are out there, like how far out on the pipe can the meter then detect the noise?
And I hate these answers, but it depends. Right?
Okay.
Depending on metal, depending on PVC, there's a distance that the acoustics can listen. But again, with all the different residential, with the meters from 5/8 to 1 inch, you have a whole population of meters out that are listening in the same service lines and distribution mains, right? So we have the ability, and we've seen, finding leaks within, 6 or 7 feet of the meter, up to a couple hundred feet of the meter. And that happens because, again, we're correlating data between the different meters and the sounds that they're hearing.
Well, that sort of leads me to my next question. You sort of alluded to it here. I'm curious, in your opinion, to elaborate a little bit on just how accurately and how close can you get to determining the location of the leak?
Yeah. Again, the more, so
it depends.
The more data points that we have, right? The more data points that we have, the closer sometimes we can get. If we have further distance between the meters, we will hear that, and then maybe we'll give the utility, say, a 20-foot or a 50-foot area where they would go with the correlation equipment to walk and find that particular leak. So they're always going to give them a location. They're going to go out and use some listening devices, because we're not going to tell them exactly where to dig. That just gives them the confirmation and shows them the spot to dig. And we have really good history with all of our customers that are using our acoustic distribution leak solution. So.
Excellent. So from what I understand about the technology, and this is a staggering number, but I'm anxious to share it with the Water Online audience, is that it has about a 90% hit rate. And when we're talking about data and being able to find leaks and detect leaks and notify the utility that there is a leak, a 90% hit rate, that's astonishing compared to what existed before. And I want to stop there and get an idea from you, Joe, like, what did utilities actually do before this?
Yeah, we're very proud. Well, I'll start before I answer that. We're really proud of the 90% hit rate.
You should be. I think that's
actually
great.
It's proving, the technology for these utilities going out. They see the meters of interest. They're going investigating, and they find a leak. Occasionally, there's a time where it's noise in the system, but 90+% of the time, they're seeing an actual leak and they're able to fix it and move along. And that's a great question. That your follow-up question around what did they do before this technology? A lot of the utilities did what they call like a distribution line survey, where effectively they hired consulting firms to go and walk their lines with correlation equipment, listening equipment, to try to find leaks. And it was probably the best solution at that point in time, because any acoustic leak sensing solution was cost prohibitive at the time. To invest in the capital, the network, the software, it was just cost prohibitive at the time. So they continued to spend money on just that manual inspection. And the drawback to that manual inspection is you could find leaks while you're walking the line, but 1 week later, after you've walked through that neighborhood, a new leak can develop, and you would have missed that, and you probably won't get to that until another year or two later when you're doing the survey again.
That makes sense. Yeah, that makes a lot of sense. And as we're going along here, there's a question that I've sort of been piecemealing together and writing down. So I'm going to look at my notes here as I ask this. So please excuse my eye contact going from here to there. But I am curious. So why should utilities use Kamstrup's metrology with embedded acoustics rather than, say, any other system? Yeah. Loggers, ground mic, et cetera.
And I think it's a bit of a continuation of like the story around distribution line surveys, because in embedded technology and the way our solution operates is it gives the utility 24/7 by 365 permanent monitoring of their distribution network. So meaning in a scenario where you're walking by and doing a survey and you catch that leak and you fix it, or a week later a leak develops, you're going to miss that, and it may be there for a whole year. With our system, you're constantly monitoring what's going on with the acoustics in the system, and as new leaks develop, they start showing up, and you start being able to monitor the history of the acoustics, which typically mean that the leak is getting worse and worse. And then you can go ahead and be proactive about your distribution line maintenance. You could take a look at the most pressing areas and put them front in line for doing any type of repair work that you need.
There's a lot of benefit there. I mean, there's not just one. It just seems like one builds off the next, and you could come up with, before you know it, there's a list of a dozen benefits that a utility can utilize and maximize when utilizing this type of technology. There's another thing that I'm curious about, and I've said many times on this show that I have never come across an overfunded utility. Right. So utilities are always measuring efficiency, always measuring dollars spent and what they're getting out of it. And all of that is important. And the solutions providers that are on top of the game understand that. And they allow the utility to know, all right, so this is actually how it's going to help you with both of those issues, efficiency and saving money. So let's talk in a broad sense. So how does a faster, more efficient leak detection solution help utilities reduce cost per identified leak?
Yeah. So it's a great question. And I always, so what we do is we give you the ability, like I mentioned, be proactive. You could be proactive with your leak detection, right? So that allows you to see when there's an issue that's starting to get bad that needs to be addressed. And that gives you the ability to go ahead and plan to be able to fix that leak. Now, the ability to be proactive gives you the ability to actually reduce that leak runtime. So for certain leaks that may never bubble up to the surface, may never show, may never be a main break, they could be running for, a year, 2 years.
Yeah, sometimes more. Yeah.
You got it. It's a smaller leak, and what that's giving us is a leak runtime. Effectively, if you were to compare like a large 10,000 gallon per minute leak that's running for 4 hours, and a 50 gallon per minute leak that's running for 33 days, you would get the same water loss, about 2.4 million gallons of water loss. And effectively, you would have found the big main break one really quick because it would have come to the surface.
Right.
But the other one, you're not going to find. So by being able to monitor that system and be able to identify when that leak actually happens, you could put it on the schedule to fix it and really reduce your water loss and your costs.
And it is amazing just how much money goes flowing right out pipes without us even knowing about it, especially from a utility standpoint. Like the fact that dollar bills are just freely flowing out of a pipe, and having no knowledge of it, and having this technology come in, being able to detect those that might have been a lot harder to foreshadow and diagnose and identify, really does come across as something that the industry sorely needed, and leave it to Kamstrup to come up with that kind of solution. So fantastic stuff. You know, Joe, so as we're talking, I'm thinking of these issues and how these questions might pop up with utility related specifically to ALD. And one of them, and it's a point that I want to make sure that we're clear on here, is that as it relates to the benefits of the solution. So one of the benefits that I would like you to elaborate on here in a minute is the fact that the acoustic leak detection system is actually already part of the AMI system. So if you have a utility that's putting out an RFP, and that RFP is for an AMI system, this acoustic leak detection add-on or added benefit to the existing offerings of AMI that Kamstrup has, it just exists within the system already. So that leads me to like the other benefit of it, that as I really see it, is that if 2 years down the line or 5 years down the line, a certain utility might want to add acoustic leak detection to their system, they're not adding another system on top of another system that's on top of their existing systems now. So there's a simplicity to it. And there's also an added benefit to it that's already ingrained within the AMI system. So Joe, could you just elaborate on that? Maybe even say it much more distinctly than I could so the utilities could understand.
No, you did a great job with that, Travis. You're absolutely right. In a lot of the requirements of the RFPs that we see out there are specifically for AMI systems. Right. The added benefit and some of the questions they ask about are what else can you do with your AMI system? And distribution acoustic leak detection is one of the things we can do. And you're absolutely right. It comes along with the meter. It's in the meter already. So if, for example, they just want to deploy an AMI system for the first few years, they can just use it as a standard AMI system. And when they want to start monitoring their infrastructure or looking for non-revenue water and distribution leaks, they could contact us. We could turn on the software, activate the software, and effectively they'll start gathering that data, the acoustic leak sensing data, and then you automatically have a distribution leak detection system that you've already deployed a couple of years ago when you put your AMI system in place. So it really is. I don't want to say it comes free because we know these systems cost money, but effectively you don't have to put any other infrastructure. All we have to do is do a software setup and start pulling that data from your head end system. So it's really, really easy to do moving forward as added functionality.
Just a phone call away. It's that simple for that added functionality. So that's very appealing, especially to utilities who are looking for an easy way to sort of flip that switch if it's so needed, as they look at their system upgrades. So good stuff. So one thing with utilities is the fact that, as a utility, we don't know what we don't know. If you don't know of a leak that you have, then theoretically, then you don't have a leak, which we all know is not true. So that's why this technology is so important. But I want to go a little bit broader than that. So if there's utilities out there that simply say, hey, I don't have a leak. There's no leaks in my system whatsoever, even though there might be, and they just don't know about it. I'm curious that with Flow IQ and as it relates to ALD, is it just for utilities that are solely focused on non-revenue water management, or could it be applicable and important for all utilities to look at?
That's a great question, Travis. And again, maybe it's a little bit of bias because I'm here at Kamstrup, but I really
go ahead.
I really think that our acoustic leak detection solution has a place for any utility. Because those that don't have a non-revenue water problem today or have new infrastructure today won't necessarily be the case 10, 15, 20 years from now. This is a 20-year 24 by 7 by 365 monitoring system. So it uses the acoustics in the distribution system to be able to truly monitor the infrastructure. So if you don't have a non-revenue water problem, the ALD technology can be used to actually monitor your infrastructure. It could give you the ability to go ahead and manage the maintenance plan for your infrastructure. And it doesn't necessarily have to be just about fixing leaks. It could be about prioritizing where that work needs to be done on your infrastructure.
So it's a wider thing than just, hey, there's this one problem that this one solution can go in and help you with a little bit. This is a wider thing. It's a systems solution that is pertinent and applicable to pretty much every utility that's out there. So that's why I was excited to actually talk about this technology, have you come on the show and let the world know this exists, this solution exists. Even if you don't know for sure if you have a problem, it's worth it to at least explore and understand how it can benefit your system either now or 5, 10, 15 years in the future, which is just as important. Because like I said earlier, there's no such thing as an overfunded utility. And I don't see money just magically flowing in as it relates to helping to curb leaks within the systems there. So Joe, I want to thank you for coming on the show and letting everybody know exactly what this technology does and how, most importantly, how it can benefit their utility for everybody across the nation. So, Joe, thank you very much. Is there anything else you'd like to add before we say goodbye and we sign off from the Water Online audience? What else is out there that we haven't talked about?
Nothing else to add. Travis, appreciate you giving us the time to talk about the technology. We're really excited about it. I know our customers that are using it are really excited about it. More than happy to come on and share some of that knowledge with yourself and your audience. So thanks so much for having us.
Of course. And for more information on anything that we talked about here today, please visit them at kamstrup.com or on Water Online. So thank you very much, Joe. And for the Water Online audience, we will talk to you later.
Thanks, Travis. Appreciate it.